Hey, welcome back to Check This Out Mathematics. I'm Mr. O'Donnell, and currently we are doing a series of videos that are lessons on logarithms. A little alliteration for you there. Okay. And so if you are liking these series of videos, then please give me a thumbs up and subscribe to my channel, and give me some comments down below. Okay, and let's give a little recap of what we've been doing. We established the idea of a logarithm. That a logarithm is asking what power of b gives us x. And so what power of the log base b of x is asking a question. What power of b is x? And since b to the n is equal to x, then the log base b of x equals n. Okay? And so that's what we want to understand, is that a logarithm, this is the logarithmic expression here, a logarithm is an exponent. N is an exponent, n is an exponent, and since n is equal to log base b of x, then log base b of x is an exponent. Okay? So that's what a logarithm is. It's an exponent. Okay. All right. And so now let's remember some properties of exponents, because that will give us some properties of logarithms, because, you know, logarithm is just an exponent. Okay, so properties of exponents. Well, what do exponents do? They tell us to multiply a certain number of times. So b to the n means b multiplied by itself n times. And so the simplest idea is b to the first is just b. Okay? And then if b to the positive n tells us to multiply n times, then b to the negative n tells us to divide by b n times. And so b to the negative n means 1 over b times 1 over b, 1 times 1 over b times 1 over b n times. Okay? And the simplest idea of that is b to the negative 1 is 1 over b. So b to the positive 1 is b, and b to the negative 1 is 1 over b. Okay, those are inverses of each other. Okay? All right? And then, so when we have a negative exponent, that means that that negative exponent, it means it belongs in the denominator. Okay? You know, if you're feeling kind of negative, don't like where you're sitting, well, maybe you like to sit down here. Then you'll be positive. Okay? All right. So a negative exponent means it's 1 over b to the n. Okay? And then we also talked about b to the 0 is 1. Okay? And now let's go into another concept here. This is property number 7. We have b to the, we have the square root of b. The square root of b. Okay. So what was this square root? You know, it's not just something that's fancy on my logo here. It's a square root. You know. Okay, so if you have b squared, well, that just means something like 4 squared is 16. 4 times 4 is 16. And then what is the square root of 16? Okay, where did this 16 come from? Well, it came from 4. It was 4 that was squared to give us 16. So what's the square root of 16? Well, it's back to 4. And when we have a square root, that's the 1/2 power. You see secretly, there's a 2 there and a 1 here. Okay, this 16 is 16 to the first. And the square root means it's the second root. Okay, so the second root of 16 is 4. And so we say 16 to the 1/2. 16 to the 1/2. And so when you have a square root, that's a fractional exponent. Okay? The root is your denominator, and the power is your numerator. Okay? And the way we simplify that is we say that 16 is 4 squared. (16) is 4 squared. And then you might remember that when you have a power to a power, you multiply the powers. So you have 2 times 1/2, and that's just 4 to the first, or 4. Okay? And so when we have a power to a power, we multiply the powers. 2 times 1/2. And half of 2 is 1, and 4 to the first is 4. So you see, when we raise something to the 1/2 power, that mimics this square root right here. So the square root of 16 is the same as 16 to the 1/2. 16 is 4 squared. And when you have a power to a power, it simplifies to 1, and you get 4. So this whole idea of having a fractional exponent just mimics the idea of saying the square root of 16 is 4. Or the square root of 16 is the same as 16 to the 1/2. Because when we take 16 and raise it to the 1/2 power, we can eventually get 4, just like we did here. Okay? So a square root is a 1/2 power. And so when we have the square root of b, we say that's b to the 1/2. Okay? And then likewise, oh, that was what happened? 4, 5, 6, 7. Okay, well, 8. Okay, I changed up my notes here. Okay, so now what is the nth power of b? Okay, so when we have the or the nth root of b, well, that means b to the 1 over n. Okay, so when we have a regular square root, well, that means that it's b to the 1/2 power. Not something squared, but 1 over 2. Okay? Okay? All right? So b squared means that we're taking b and multiplying it by itself. Okay? And so now, if we don't want to square something, we want to square root it. And so then, instead of having 2, we have 1/2. Okay? And then if we want the nth root of b, well, we say that's 1 over n. Okay? And so that's the idea. If you want the third root of b, well, that's just b to the 1/3. Okay, that's the idea. Okay, so we can have a square root, that's b to the 1/2. We can have a third root, that's b to the 1/3. And in general, the nth root of b is 1 over n. Okay, so there's our properties of exponents. Okay, b to the n is b times b times b, n times. B to the first is just b. And so then b to the negative n is 1 over b times itself, n times. And so the simplest case, b to the negative 1 is 1 over b. And then another way to look at this is b to the negative n is 1 over b to the n. Okay, so what does it mean when you have a negative exponent? It means it's in the denominator. Okay, and then b to the 0 is 1. And then the square root of b is b to the 1/2. Or the nth root of b is b to the 1 over n. Okay? All right. Let's see. Now we want to look at the equivalent properties of exponents. Not exponents. Logarithms. Well, wait a second. A logarithm is an exponent. So they're properties of logarithms, the same as properties of exponents. Okay. Properties of logarithms. Properties of logarithms. And logarithms are exponents. And so we have all these properties of exponents. We must have equivalent properties of logarithms. Okay. So remember here that we had this property that b to the first is b. And so the way to write that in logarithmic form is to say log base b of b is 1. Okay, all right, so remember the logarithm is asking what power of b gives you b. What power of the base gives you the argument. Okay? That's what we talked about here. This was our overall properties of the overall relationship between exponents and logarithms. B is the base and x is the argument. And so what power of the base gives us the argument? And so when we see this logarithmic statement, what power of b gives us b? Well, it's b to the first that gives us b. Okay. And so, for example, if we know that 4 to the first is 4, then what is log base 4 of 4? Okay, if we know that 4 to the first is 4, then what is log base 4 of 4? What power of 4 gives us 4? Well, it's the first power. Okay, so the answer to a logarithm is the power. That's what we're wondering when we're wondering about a logarithm. We're wondering what's the power. Okay. All right. Number 2. If we have b to the n is b to the n. Okay, something that's true there. And so how does that appear in logarithmic form? That is log base b of b to the n. Okay? What power of b gives us b to the n? It's the nth power of b that gives us b to the n. Okay? So what power of b gives us b to the n? It's the n power of b that gives us b to the n. What power of b gives us b to the n? It's the n power of b that gives us b to the n. Okay, so remember, this is our round trip. The round trip is going to make things really make sense for you in logarithms. Okay, so what is the log base b of b? Well, it's 1, because b to the first power is b. What power of b gives you 1? And what power of b gives you b? The first power of b. b to the first is b. What power of 4 gives you 4? Well, the first power. 4 to the first power is 4. The round trip. And what power of b gives you b to the n? Well, it's the n power of b that gives you b to the n. And so b to the n is b to the n. B to the n is b to the n. Okay, so there's your properties of logarithms. Okay, log base b of b is 1, and log base b of b to the n is n. Okay, let's look at an example of that second property. Okay, if we have 3 to the 4th, that's 3 to the 4th. And so how do we write that as a logarithm? We say log base 3 of 3 to the 4th is 4. Okay, what power of 3 is 3 to the 4th? Well, I bet it's the 4th power that makes 3 to the 4th become 3 to the 4th. And it is. Okay, all right, so the logarithm is asking what's the power? What power of 3 becomes 3 to the 4th? And there's the power right there. And so there's the answer right there. All right. Okay, and we also know that 3 to the 4th is 81. You knew that, right? Okay, so that's 3 times 3 times 3 times 3. And that's 9 times 9. That's 81, isn't it? Yeah, if you multiply 3 by itself 4 times, well, 2 3s give us 9, and 2 more 3s give us 9, and 9 times 9 is 81. So 3 to the 4th is 81. And so when we say log base 3 of 81, well, what power of 3 is 81? Well, it's the 4th power of 3 that gives us 81. And so that's what we put. 3 to the 4th is 81. All right, pretty cool stuff, right? Yeah, logarithms are awesome. And remember your round trip. That's how you get back to where you started. Okay? Log base 3 of 81. What power of 3 is 81? It's the 4th power of 3 that's 81. So 3 to the 4th is 81, and it gets us back to where we started. Good stuff. Okay. All right, more properties of logarithms. Okay, properties of logarithms. Okay, here we go. Number 3. We have b to the negative 1 is 1 over b. How does that look as a logarithm? Well, That's log base b of 1 over b. So what power of b gives us 1 over b? Well, we would have to raise b to the negative 1 power to get 1 over b. And so log base b of 1 over b is negative. What power of b is 1 over b? Well, b to the negative 1 power is 1 over b. Okay? Okay, compare that here. What power of b is b? It's the first power. What power of b is 1 over b? It's the negative 1 power. What power of b is b? The positive 1 power of b is b. What power of b is 1 over b? The negative 1 power of b is 1 over b. So what do negative exponents do? They give us fractions. Okay. Remember, Mr. O'Donnell is partial to fractions. Okay. Think about that a while ago. Maybe you'll get a chuckle there. Okay. Okay. So here's an example of that. If we have 2 to the negative 1, that's 1/2, right? And so log base 2 of 1/2 is negative 1. 2 to the negative 1 is 1/2. What do negative exponents have the power to do? They have the power to make fractions. Okay? And so how does 2 become 1/2? Well, you need the negative 1 exponent to make 2 become 1/2. All right, good stuff. Okay. All right. So a few more powers of logarithms. Okay. Remember this power here, this property here? B to the negative n is 1 over b to the n. Okay. And so now then, how does that look as a logarithm? Well, that's log base b of 1 over b to the n. Okay, how does b become 1 over b to the n? Well, you need a negative n power to make that happen. Okay, so if you want b to become 1 over b, you just need a negative 1 power. But if you want b to become 1 over b to the n, well, then you need a negative n power. Okay. Okay. If you want b to become b to the n, you need a positive n power. If you want b to become 1 over b to the n, well, you need a negative n power. Okay. Okay, so check that out. Over here, we want b to become b to the n. That's the positive n power. Over here, we want b to become 1 over b to the n. That's the negative n power. Okay. All right. What property am I on? Okay, that was 4. Okay. All right. Yes. Remember this property? B to the 0 equals 1. How does that look as a logarithmic statement? Well, that's log base b of 1 is 0. Okay? So log base b of 1 is 0. What power of b gives us 1? It's the 0 power of b that gives us 1. It's the 0 power of b that gives us 1. How do we make b become 1? The 0 power will do it. Okay. 6 b to the 1/2 is the square root of b. Okay, remember that property? All right, now how does that look for a logarithm? Log base b of the square root of b. Okay, how do you make b become the square root of b? Well, you need a 1/2 power. Okay, so check this out. If we have log base 9 of 3, what's log base 9 of 3? Well, how does 9 become 3? Well, I bet if we take the square root of 9, we'll get 3. Or that's 9 to the 1/2 that gives us 3. Okay, so it's the square root of 9 that gives us 3. Or that is 9 to the 1/2 power that gives us 3. And so how does 9 become 3? Well, you'll have to take the square root of 9 to get 3. Or you'll have to raise 9 to the 1/2 power to get 3. Okay, so log base 9 of 3 is 1/2, because 9 to the 1/2 is 3, because the square root of 9 is 3, and the square root of 9 is the same as taking the 1/2 power. All right, awesome stuff. Okay. All right. All right, number 7, properties of logarithms. Okay, we have b to the 1 over n is the nth root of b. Okay, so when we have a fraction here, that means it's a root. So how does that look as a logarithmic statement? Log base b of the nth root of b is 1 over n. Okay, how do we make b become the nth root of b? Well, we'd have to raise b to the 1 over n power, and then we would get the nth root of b. Okay. And now 2 more properties. And we'll talk about these a little bit more in length in another segment here. We're just going to write these down. What is b raised to the log base b of x? Okay, well, remember, I'm going to keep you in suspense here of how this is true. But for now, b raised to the log base b of x is x. Okay, that's a property of logarithms, and there is a reason why. Okay, all right, we're going to talk about that later on. And then one more cool property. If we have log and we have b and we have a there. Okay, we'll get ready for this later on. Okay, so I have the log and I have it, the base is b to the a. That's my base. Okay, who comes up with this stuff? Okay. Okay, so the base is b to the a, And so the log base b to the a of c is the same as the log base b of c raised to the 1 over a power. Okay? So when we have an exponent down here in the base area, we can jump it up to the argument, and it flips 1 over a. Okay, that's another cool property. We'll talk about those later on. Okay. That's it for now. Thanks for tuning in to check this out, mathematics. Like my channel, subscribe, like these videos, give me thumbs up, and put some comments down below. And we'll be back later on.